S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, as we have discussed in the previous video about the digital communication. So in this video we will discuss about the transmission media.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
Welcome to SN Academy. My name is Kanhaiya Jha, and today we will discuss about the different kinds of transmission media and how it takes place. So we can discuss here that what is the wired communication, what is the the skywave propagation and all that. So we have first the unguided transmission media. The unguided medium transport electromagnetic waves without using a physical conductor. This type of communication is often referred to the wireless communication. Signals are normally broadcast through the free space. Basically, it is the example of the space communication where the electromagnetic waves are propagating, and when the electromagnetic waves are propagating, they will flow from the input given to the desired output. They will flow from the one particular input to the particular output. So we say that in the communication, transmission communication in a unguided medium, we have a space communication where the signal which is in the form of the electromagnetic wave, the signal which is in the form of the electromagnetic wave will generally flow from the one particular media to the another particular media, and they will not follow any particular cable or any particular line. Then we have convergence. The first thing that we have is in the transmission media, the guided media and the unguided media. We have in the guided media the cable communication where we have twisted pair, coaxial cable, fiber optics cable. Then we have the unguided media, and in the unguided media we have a radio communication, we have a microwave communication, and we have a satellite communication. So these three things we have in this transmission. We'll discuss one by one that how we are going to use the twisted pair communication, how we are using the coaxial cable, and how we are using the fiber optic cable. Then we have unguided media where we are using the radio communication, then the microwave communication, and then the satellite communication here. So first of all, we need to understand that how the signals are broadcast. In the earlier studies, we have done the circuit analysis, that how the transducers are generally used, to send the one particular signal from one particular point to another particular point, how the conversion of the original message to the electrical signals are done, and then again the conversion of the electrical signal to the original message is generally done. So by the conversion, the original signal can transfer from the sender to receiver. Here we have the wireless communication. The communications are not using any particular wire. So when they are not using any particular wire, then the range of the communication becomes very high. As we have seen that they are capable of receiving the signal from one point to another point. So they are called as unguided media, because unguided media we are using here is we are without any use of a particular wire. This particular is very safe also, that the range it becomes very high, the cost also is not that high, it becomes less because the cost of the wire is generally deducted. Then we have unguided media types. We have unguided media types as a ground propagation, sky propagation, line of the sight propagation. So we have in ground propagation the radio waves. So basically this particular type of propagation generally depends upon the frequency and the nature of the communication used. So as we are varying the particular frequency, as we are changing or we are moving from the lower frequency to the higher frequency, then we can analyze these particular changes as we are going from the lower frequency and then we are moving to the higher frequency. So, the ground propagation, sky propagation and the line of sight propagation, these are the propagation that we generally analyzed in terms of the communication channel. So, in the sky propagation, higher frequency radio waves radiate upward in the ionosphere where they are reflected back to the earth. The line of sight propagation, very high frequency signals are transmitted in straight line directly from antenna to antenna. So, depend upon, as we have said, that the type of the communication depends upon the nature of frequency used. As we are using the lower frequency, or we are working on a lower frequency, or we are working on a higher frequency. So, let us discuss in a detail that how there is an antenna, that antenna absorbs a particular signal, it sends to the electrical circuit, and then that particular electrical circuit process the signal and then they translate into the original form. So, what we are getting is that we are getting the signal translated in the original form when they are carried out from the one point to another point. So, all this depends upon the frequency generally used. The sky propagation is basically used, what are the frequency that we generally used in this. Then we have the wireless transmission has radio wave, microwave and infrared. We will discuss now. Radio waves is generally used for the lower frequency, for the higher wave microwave and then the infrared frequency, depending upon the nature of the frequency generally used. So, we have a communication system in which we have a sky wave propagation, we have a line propagation, we have the communications which are connected with wires, and depending upon the nature of frequency that are used, depending upon the nature of frequency which are required, which generally forms the nature of the particular channel. So, first one we have discussed the line communication which uses the wire, then unguided media which do not use the wire, we use the space configuration, and then a very important concept, optical fiber. Optical fiber, what we do is that the particular rays generally travels with the optics, or we say that it travels with the speed of light. When they travel with the speed of light, then the speed becomes very high, and the optical fiber or the optical communication is a very key role in the today's transmission. Either we are dealing with a mobile technology, either we are dealing with the satellite communication, mobile communication, in every part optical fibers are used. So, we have discussed about the different communication channel and how they are dependent upon the frequency. So, now we will take a small break and then we will proceed further.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back, students. So, we have discussed before the break that what is a communication channel is, how the frequency is important, how we have to analyze the frequency. So, just recalling the previous concepts, what we have done the different kinds of frequency, we have done the different types, what is a sky wave frequency, what is a unguided media, what is a guided media, how we are taking the particular communication with the particular connecting with a particular wire. In that case, the range was small, we have learned. Then the same thing was developed in the sky wave propagation. Now, we will discuss further that the different categories of this. So, different waves, so microwaves. So, microwaves used for the communication such as the cellular, cell phones, satellite networks and the wireless. So, basically we have three networks here. The smaller network that we form, we connect 2-3 computers and we form a smaller network, that is called as a local area network. When multiple local area network is connected, then it becomes a main area network, and then wide area network, and then the different wide area networks are connected, then it becomes a main area network. So basically if we focus here, so we have LAN, we have WAN, the wide area network, and then the main area network. So here depends that the communication system that we are using is used where, either it is using in LAN or it is using in WAN or it is using in MAN. So either we are using it for the local network or we are using it for the wide network or we are using it for the particular main network, and then the frequency. Here we can see that the microwave frequency 1 to 300 gigahertz. So microwave are generally used for the satellite communication, we can use it for the mobile communication, we can use for the telecommunication, because we can see that the range is high, we can use for the higher frequency. Then we have the next one, infrared frequency, that depend upon, that generally varies from 300 gigahertz to 400 terahertz. So they are generally used for the short range communication in a closed area using line of sight propagation. So we'll make a range of this and we'll decide the range, that how they are using from the one particular point to the another particular point, how they are using it, how we are using it in a different line of sight. Then we have the third one, which is the wireless propagation, that depends upon the up to 2 megahertz that we have said. We are using it for the radio propagation, we are using it for the skywave propagation, we are using it for the line of sight. So signal travels from three parts: the ground wave, follows counter of earth up to 2 megahertz, and then we are using it for the radio propagation. Then we are using it for the sky wave, where we are using the armature radio, BBC World Service, Voice of America. These are the basically name of the channels, and these channels are always available to us on a very high frequency. So either we are watching these channels on the TV or we are listening them on the radio, they are always on the very available on the very high signals. Signals reflected from the ionosphere layer of the upper atmosphere, the signals which are available on the ionosphere on the upper level, and the line of sight that we decide above 30 megahertz or maybe further than optical line of sight, that we can say. Then here we see the ground wave propagation, how the ground wave propagation generally occurs between the different antennas. So we can see this is the earth, this is the transmission media 1, and this is the receiving antenna. So we can see here that the propagation is occurring from one antenna to the another antenna. The propagation is occurring from one antenna to the another antenna, where the signals are traveling from the one antenna to the another antenna. Signals are propagating from one particular antenna to the another particular antenna. So this is the earth, and from the earth these propagations are generally calculated. So we can see here that in the earth atmosphere, if we take an example here, that this is the surface and this is the one antenna A, B, C, D, and this is the particular signal which is coming. So A to B it can flow, from B to C and from C to D, or directly it can flow from A to D or B to A, it can flow. So we can see that this how it can flow. So every time the antenna is connected, so if A is connected to B, the signal is flowing from A to B, it can flow from B to A also. What I mean to say is that if antennas are connected, antennas plays a major role for the propagation of the wave. That when the waves are propagating from the one particular point to another particular point, then the antennas plays a major role. So we can say that if antennas are connected, then the signal can flow from the one particular form to the another particular form. So here it is moving from A to B, B to C, C to D. As we can see in this particular diagram here, that two antennas are used. One is a transmission and one is a receiving antenna. So from where it starts, it is called as a transmission antenna, and then where it reached is called as a receiving antenna, and this is a signal propagation. So this is a signal propagation where one is a transmitting antenna and the another one is a receiving antenna where they are directly received. So, depending upon this, this is called as a ground wave propagation. And why it is called as a ground wave propagation? Because it is always happening on a particular surface of the ground. That antennas are connected, and on a very low frequency, this particular the transmission goes from the transmitter to the receiver. The transmission goes always from the particular transmitter to the particular receiver. Then we have sky wave propagation. We can see the sky above, this is Earth's surface, above it, between the ionosphere. This is a transmitting antenna, this is the signal propagation, and this is a receiving antenna. So, one was done on the surface, now it is done on the ionosphere. So, when it was done on the surface of the Earth, we say it was a ground wave propagation, and here it is a sky wave propagation. Wave propagation is basically that how the different waves are moving and how we are calculating their propagation and how they are carrying messages from the one particular point to another particular point. So, when they are carrying the message from the one particular point to another particular point, then we say that they are processing the ionosphere from the one part to the another part. So, one was a ground wave, and here we can see that above the surface of the ground. So, when we are saying above the surface of the ground, then it means that they are propagating with the particular on the ionosphere. They are propagating on the ionosphere when it is propagating from on the surface of the particular Earth. So, again in this we can see that either on the ground or above the ground, all these generally matters when we are calculating with a particular frequency, when the variation in the particular frequency is calculated. Then we have the line of sight of propagation, where we see the Earth, this is a transmission antenna, and then we fix the propagation, and that becomes a receiving antenna. So, line of sight is basically LOS, propagation above 30 megahertz. We set the particular frequency, and depending upon the set frequency, the communication is generally done. So, here we have learned three things. One is the ground wave, where the two antennas are on the surface, and we are studying the propagation of the wave on the surface of the Earth only. Then we have a sky wave propagation, where the antennas are on the ground, but we are calculating the propagation above the ground. And then the line of sight. In the line of sight, what we generally do is we fix the particular frequency. That frequency, yes, but of course it has to be above the 30 megahertz. So, we fix the particular limit of the frequency, and when we fix the limit of the particular frequency, then the communication is done on that part of the particular frequency. So, one is a ground wave propagation, one is a sky wave propagation, and one is a line of sight. In the line of sight, we generally check that the frequency is set and the communication is happening. So, we can see there in the initial figure, you can see the antenna is here, antenna is the last, but here you can adjust the antenna. After fixing the particular frequency, we can fix the particular antennas also. Then we have satellite microwave. Satellite microwave is basically which receives the particular wave in a particular frequency, and then it sends to the particular receiver. It sets the particular frequency, and on that particular frequency we set the particular channel. So, why the geostationary orbit, height of 35 or 785 kilometers, we can use this on a transmission of televisions and then the telecommunications and all. This basically is also used, this particular channel can also be used when we set the particular frequency. So, in totality what we have learned in this particular video is how the different kind of propagations are generally made. We have discussed that what is the ground wave propagation, we have discussed what is the sky wave propagation, and after this we have discussed that what is the line of sight. In the ground wave propagation, we set the antennas at the ground and we calculate the variation occurring at the ground only. And in the sky wave, what we have learned that the antennas are set at a particular ground, and then the propagation is studied above the ground. We can see here above the particular ionosphere. Then line of sight is basically that when we set up a particular frequency, and then we calculate the variation in the particular frequency. Setting up a particular frequency can be used for many purposes. It can be used for a defense purpose also. It can be used for any private communication also. For example, that suppose that the team of the particular defense is working on a very high mountain where there is no communication channel. We can't make any communication, but they can make, because we make a set a particular frequency where the defense people among themselves can make a communication, and then they can make a communication with their control systems also, the control unit also, the team which is monitoring everything. So line of sight is a very important term. We are using it for the many purpose from day to day life. Then we have discussed the wave propagation, that nature of the wave used. Every time we have discussed that the nature of the wave used is an electromagnetic wave, and the nature of the propagation that is used is a sinusoidal propagation. Sinusoidal propagation, when the elements of the electric wave and the magnetic wave, they are overlapping with each other, they are in the perpendicular form with each other. So this is basically the nature of the waves: sky wave propagation, ground wave propagation, and the line of control. Used with the communication industry, television industry, used in the radio industry, everywhere it is used. We have discussed the guided and the unguided media, how the wires are generally used, and when the wires are generally used, then what are the limitation of the particular wires, that how the range is becoming small. We will discuss a very important concept here, that what happens when this is the antenna, here we are using antenna A, and here we are using antenna B. So we can see that if this is a transmitter, then the information will go towards the receiver. So this process, when it goes from the transmitter to receiver, we need one thing very important, is what is the set of frequency used. What is the range of frequency that we are using? Here we have discussed in earlier topics that here also we are using a transducer, here also we are using a transducer. Here the original message that we have will be converted into electrical signals, then it will process, and here the particular electric signal will be converted into the original message. So what we will get here is, in the input we are giving the original message, and in the output also we are getting the original message. So this is basically the root thing of the communication. Either we are using a ground wave, or we are using a sky wave, or we are using a line of sight. Line of sight here, that as mentioned, that more than 30 megahertz, we fix a particular frequency. On that particular fixed frequency, we make the communication channel. On that particular fixed frequency, the communication channel is generally moving from the transmitter to the receiver. Then we have discussed the elements of sky wave propagation, the frequency range from 2 to 30 megahertz, it is generally used. We have discussed the range of the sky wave propagation, we have discussed the range of the line of sight, and we have discussed the minimum range for the line of sight. So depending upon this, we can form the communication. We have discussed about the phase, amplitude, frequency of the wave, how the wave generally varies, how the particular frequency matter in the waves, nature of the waves, nature of the propagation of the waves generally matters in the communication systems. We have discussed the particular optical fiber, how they are important, how they are basically used to enhance the speed of the communication, and this. So if we focus that, we have discussed in the earlier slides, that guided and unguided media, that in how the guided media and the unguided media, how we are using a wire in the guided media and how the wire is not required in the unguided media. So this forms the basics of the particular particular transmission media that we are using, that what are the different parts and different types of transmission media, and how in every case the frequency matters, the range matters, how we have developed a particular communication called as a line of sight and how it is used. Depending upon the nature, the requirement and the uses, we form the line of sight. We have taken the example of the defense, that at any part they make their network and then it is used. So like this we can form the smaller networks also, we can form the big networks also, depending upon the frequencies. Here we can see that the frequency range is given, either it is the ground wave or it is the sky wave or it is the line of sight. The frequency range is given for this and then we make it. So we have discussed here the different kind of the communication system is a sky wave. Again the frequency range is given from 2 to 30 megahertz. We can say that the line of sight which is given for above 30 megahertz, before that it cannot be, less than it cannot be used. So we have discussed the different transmission media, we have discussed the guided, unguided, ground wave, sky wave, line of sight, the frequency, and then how it travels from antenna to antenna and from transmitter to receiver. Hope you have enjoyed this video. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.